Okay, question 4.6. The activity of an enzyme in micromole per min has a linear response in the pH range shown in figure 1 and at the two temperatures T1 and T2. Using the data in table 1 below, estimate the pH at which enzyme activity is equivalent at T1 and T2. So I'm trying to find the coordinates of the points at which these two lines intersect, okay? Which to me, assuming that there's a linear response between them, could be at a pH of about 6.75 and an enzyme activity of about 1 point something. Okay, so we're going to do that now. Right, so here's that data table, which I've copied and pasted into a OneNote. And so what I'm going to do is I've got to work out the y equals mx plus c of each of those lines at T1 and T2. Okay, so let's do T1 first. Here we go. Let's do a T1 for T1. Well, I got 2 data points, and that means, let's have a look. That means I've got a point here of a y value of 0.60 equal to 6.3. Actually, I should do it the other way around. Okay. We don't know what the gradient of this graph is yet, so let's call this m1 times 6.3 plus c1. Okay, and of course I've got another data point which satisfies that straight line, which is 2.4 is equal to m1 7.9 plus c1. Okay, so I can work out what m1 and c1 is because that's just a simultaneous equation. So what I'm going to do here is I'm going to let's do from 1 c1 is equal to 2.4 minus 7.9 m1. Let's substitute that in 2, so that I've got 2.4 is equal to 7. Oops, sorry, made a mistake here, haven't I? It's not 7.9, that's 6.3. So I'm going to do 7.9 m1, and I'm going to substitute that in for the c, which means I get minus or plus 2.4 minus 6.3m. Making mistakes here, aren't I? Okay, this isn't, I should have rearranged this, so this wasn't 2.4, this was 0.6. Okay, stay with me guys. 0.6, that's 0.6. 6 minus 6.3 m1. Okay, so let's get m1 out. So m1 is equal to 2.4 minus 0.6 all over 7.9 minus 6.3. Okay, let's get an answer for that. Gives me 1 point, let's do it to 2 sig fig 1. Okay, now that means that C1 is equal to 0.6 minus 6.3 times 1.1. I'm actually going to use the value of 1.125, which I just calculated. 0.6. And then, so I actually get a value of C here of minus 6.5 to 2 sig fig. That's 2 sig fig as well. Okay, right, so that's the first line done. Let's highlight those. Okay, and what I'm going to do is I'm going to do for temperature 2 now as well, right? So what I'll do here is I'll bring this down. Oops. Can I move that now? Let's put this over here now, okay? I'll put it back where it was. There it is, that's what I wanted to do. Put it over here this time. Right, now for at T2, I got to do the whole thing again. Okay, so I'm going to say this time it's 0.9 is equal to M2 this time times 6.3 plus C2 1, and then I've got 1.6. I'm going to sneeze. No, I'm not. No, I'm not good. Is equal to 7.9. There. Check I'm doing that right. Yeah. And that's equal to plus C2 again. So again, from 1, C2 is equal to 0.9 minus 6.3 M2 subs in 2 to get 1.6 equals 7.9 M2 plus 0.9 minus 6.3 M2. Doing some jiggery-pokery, I get a value for M2 which is equal to 1.6 minus 0.9 all over 7.9 minus, oh, yeah, that's right, 6.3. Value for that, 1.6 minus 0.9. Gives me a value of 0.37. Oh, 0.4375 or 0.44 to 2 sig fig. And actually, if you look at it, I've only got 1 sig fig here. So this should really only be to 0.4. Okay, I'm going to use this value in my calculation of C2. C2 is equal to 0.9 minus 6.3 times 0.4375. Okay, that gives me a value of 0.9 minus 6.3 times, that gives me a value of minus 1.856, which really, because I'm subtracting these, should have the same number of decimal places, so that's minus 1.92 sig fig, okay? Right, so there you go. I've got now C2 and M2. Okay, so let me just write those down quickly. I've got M1 is equal to 1.1, and I've got I don't want to be using that. Let me get that. And I've got C1 is equal to minus 6.5. Okay, and I've also got M2 is equal to 0.4, and I've got C2, that's a C1, C2 is equal to minus 1.9. Okay, so what I've got now is I've got the gradients and the intercepts of both of those lines, and those two lines meet. Now to find the points at which they meet, I'm going to use my gradients here. So I'm actually going to construct a final simultaneous equation scenario. Let's do it in blue. So I'm going to say y is equal to m1, which is 1.1 x, plus c1, which is actually minus, is minus 6.5. Okay, and then I'll do it again. Y is equal to 0.4 minus 1.9. Okay, brilliant. Now, those, I can solve that again simultaneously, this time to get the values of y and x, okay? Because at the point of y and x, those two lines meet. So I'm just going to say from 1, let's have a look at this. Well, I'm going to substitute that in. So y is equal to that. So I'm just going to substitute that straight in. Subs 1 into, get rid of that. And I'm going to do 1.1x minus 6.5 is equal to 0.4 minus 1.9. Okay, let's collect the x terms on the one side. So that's 1.1 minus 0.4, which of course is 0.7x. And then I've got minus 1.9 plus 6.5 on the right. Too lazy to use my brain today, so that's going to be minus 1.9 plus 6.5 is equal to 4.6. Okay, which means that x is equal to 4.6 over 0.7 equals about 6.57. 5714, which really should be, we've only got this value here to 1 sig fig, right? Let me just check that. Is this 1 sig fig? Yeah, that looks right to me. So really, I should express that to 1 sig fig, which would be 0.7. That's silly, isn't it? So I'm just going to call it 2 sig figs. So let's call it 6.6. Okay. Okay. And then I know that if I know what x is, then y is, I'm just going to use 1 again, is equal to 1.1 times 6.6 minus 6.5. In fact, I've only asked you to tell me what the pH was. Okay, so I've already answered it, but I can tell you the enzyme activity of that as well. I'm actually going to use this value here to calculate this. Still on my calculator, I'm going to multiply that by 1.1 and then minus 6.5. I get a value of about 0.7, and again 1 sig. I can only use 1 sig figure there on decimal. Okay. Now I've been a bit naughty here because I haven't really played ball with my sig figs, but it was a bit of a tricky question, to be honest. A lot of workings out. I'm sure we could have found a simpler way of doing it, but that's the way I did it. Now, just in case you're anxious about the sig figs there, I played very fast and loose. In an exam situation, I'm going to be far more explicit in giving you the correct number of sig figs to work with. Okay, bit of a badly designed question, I'm afraid, that one. Sorry. Okay, so I hope that helps.